I'm going to describe how to use this interactive simulation, which solves the differential equations for a batch reactor in which two reactions are occurring in series, A reacting to B and then B reacting to C. What the simulation will plot is the concentrations of the individual components, or if I select all, it'll plot concentration of A, concentration of B, and the concentration of C. Now notice for this reaction, you can change the temperature with the slider, and this is going to affect the reaction selectivity, which is the concentration of B over the concentration of C. So at any point we're calculating selectivity is that ratio of concentrations. Because the activation energy is larger for the second reaction, so as we raise the temperature, we're going to favor the second reaction. On the right, we can also select the selectivity, so we can see the selectivity is high initially. We don't have much B, we can't have much B reacting to C, and the selectivity decreases as we move through the reactor. The idea is we can change the temperature and observe the effect of the concentrations of the various components and the selectivity. This simulation is located on the Wolfram site, and so what we're going to do is go to that site and look at the simulation. So here's the simulation on the Wolfram site. And you can see when I've selected all, I could select just the concentration of A. But if I select all, then I see the three concentrations. And as I change the temperature, notice that the reaction goes to completion at a shorter time. And indeed, as I change the temperature enough, notice that the time scale changed. Let me go back. As I went above 465, the time scale changed. And I'm getting almost complete conversion of product C at shorter times. I can also look at the selectivity. Selectivity is high initially. It's the concentration of B over the concentration of A. And as I raise the temperature, the selectivity goes down because the activation energy is higher for the second reaction. So you can go to the Wolfram site and change the temperature, try to get a better understanding of the behavior for series reaction and a batch reaction.